Hey guys, welcome to a new video. Today we'll be learning about enzymes. Okay, here. So if I can finish them all of these points or the entire unit in one video. Okay, so first, enzyme. What is an enzyme? Enzyme is a protein. Okay, so it's a protein. It is a protein. Wait. It's a protein that acts as a biological molecule. Biological catalyst. Acts as a biological catalyst. Okay, now remember this, it's really important. Enzymes are proteins. They are proteins, but they act as biological catalysts. Now, catalyst, biological, you know what it means, but catalyst is a substance, and its function is that it increases the rate of reaction increases the rate of reaction. That's one of the functions, right? And that's the main function. And another thing you should know is that it increases the rate of reaction without being used up itself. Without being used up itself. Yeah? Now, so since it's not changed, we can say that enzymes can be used over and over again. So no matter how many times you want to use it, you can use it. It's used over and over again. Whenever your body needs it, it's used over and over again, since it is not used up in the reaction. It's without being used up in the reaction. Another point that you should know is that since it increases the rate of reaction, your body needs it. Okay, so your body obviously needs to be fast, right? So your body needs to be very, very fast. So enzymes help your body function more fast. Now, if you wouldn't have any enzymes, let's say your body did not have any enzymes, then that would just mean that your body would function, or the reactions would occur slowly, just enough to be alive. Reactions would occur too slowly for us to be alive. Since our body needs to be really, really quick in everything, literally everything. Okay, so now enzymes. Now I'll talk about enzymes and how they work. So let's say this is an enzyme. This is an enzyme. Okay, this part is the active site. Not just this place, like the place where another substance enters is called an active site. Okay. Now, the substance that enters this active site is called a substrate. Substrate. Yeah. Now, this is the substrate. What happens is that, okay, the substrate doesn't enter first. So the substrate is over here. I just want to show that it enters. Substrate. This is the first part. This is number one. Number one. This is what happens. Number one is this. Number two is, this is your enzyme. And this is your substrate. One thing you should know is that this active site, this is the active site again, it's made, so the enzyme's active site is made just for a specific substrate. So only this substrate can enter. So this enzyme is made specifically for this substrate. So they are specific. Now when this is formed and they're stuck inside, like, so they're stuck to each other, we call this the enzyme substrate complex. Enzyme substrate complex. Okay, now that is the second part. Now the third part is that this enzyme will, okay, so this color was purple. It gives this and this. So it gives these products. So what you can make out by this is that, okay, this is the third part. Now, first it was this big substrate. It was this big block of substrate, and it was fixed into this enzyme, right? And we called it the enzyme substrate complex. Now, this enzyme, what can you think that it did? It broke down that substrate, that big block of substrate, into two substrates. Okay, so these are called the products, and this is catabolism. So it's when this substrate, it catalyzes into other substrates. So this is catabolism. Okay, this entire process may also happen in, it can also be used for, anabolism. Anabolism, which is building up. Catabolism is breaking down. Okay. So till now we defined a catalyst, we defined enzymes, we described why enzymes are important, and the shape. We showed this. We said this. Now, investigate and describe the effects of changes in temperature and pH on enzyme activity. Explain the effects of changes in temperature on enzyme activity in terms of kinetic energy, shape and fit, frequency of effective collisions, and denaturation. Now explain the effect of changes in pH on enzyme activity in terms of shape and fit and denaturation. Denaturation, whatever. Okay. Now, for temperature. Okay. If I draw a graph for temperature, it's going to look like this. This is 0 degrees. This is 20 degrees, 40 degrees, 60 degrees. What happens is it goes like this first, then it goes like that, then it goes like that. Okay, so this, and this. Actually, it reaches here. Okay, so what does this graph show? It shows that at low temperatures, so between here, it's increasing, right? It's okay, so this is the enzyme activity, right? Enzyme activity. And over here, it's the temperature. So the x-axis represents temperature and the y-axis represents enzyme activity. Now, when the temperature goes from 0 to 20, it's increasing. So the temperature is low right now. So 0, it's low. So it's like not doing anything. It's over here. When it increases, so at 0 temperature, molecules, the enzyme activity is at 0. Why? Because there's no temperature. If you know this, like temperature, it's directly proportional to kinetic energy. So as temperature increases, kinetic energy increases. As temperature increases, the molecules move faster. Okay, so enzyme activity will increase. Okay, so over here it's 0 because molecules have very little energy because of temperature, which is low, and less chances of successful collision. So when temperature increases, you go faster and you collide more, which gives more enzyme activity. At high temperature, so it goes higher, so the enzyme activity is increasing. Now, at high temperature, okay, over here, it goes till here, this point over here, which is at 40, is the optimum temperature. It's the optimum temperature, right? So this is the highest point, or the point where enzyme activity works at the best, right? So it goes up, it increases till here. Over here, it's the optimum temperature. It's where the enzyme activity is at its peak. So it's the top, and it's at 40 degrees. Now this is okay. So now it starts when it reaches 40 degrees. It starts declining. Okay, it goes down and down and down and down. Over here, in this part, do another color. Here. At this part, what happens is that temperature increases and bonds in the enzyme break. Okay? When bonds in the enzymes break, the active site, what we discussed earlier, the active site where the substrate, where it's in the enzyme and the substrate fits in it, and active site changes shape. If the active site changes shape, that means that the substrate cannot fit anymore. And if the substrate does not fit anymore in any of these enzymes, when the substrate stops fitting, and there's going to be no reaction, so substrate does not fit anymore, and with a high temperature, it causes denaturation. And denaturation usually happens at 60 degrees, so it's literally dead over here. Okay, so I'll say it again. Okay, so over here at 0, the enzyme activity is 0 because it needs temperature for it to move, right? So enzyme activity will be 0. As it increases, I'll do it black. As it increases, the enzyme activity also increases because temperature is directly proportional to kinetic energy. So as temperature increases, the speed of each molecule increases. And if the speed of each molecule increases, the enzyme activity increases. It goes to a point and it reaches the top point, the point that it's the best for the reaction, right? So which is 40 degrees. Yeah, and then it reaches here. Once it goes above 40 degrees, it starts going down and down and down and down till it reaches 60, which is the denaturation. In this point, or this place, first the enzyme breaks. Enzyme bonds break. Then the active site is changed, obviously. It changes shape. Then the substrate cannot fit anymore, and finally it's the denaturation. Denaturation or denaturation, I don't know how to say it. I know how to say it, but I don't know if it's the same way everyone says it. Okay, this is for temperature. That's for temperature. Now, okay, for pH. For pH, the graph is okay. So sorry. This graph, it shows enzyme activity and pH. So pH is on the y-axis, pH is on the x-axis, and enzyme activity is on the y-axis. Okay, so it's the graph is like this, being 0, 14, and 7. Okay, so pH of 7. Okay, just to recap on something, I don't think the syllabus requires it, but just to understand, 7, anything with pH 7 is pure water. I don't know if it's pure water or water. I think it's it's pure water. And between here and here, so 0 and 7, or 7 below 7, it's acidic. And between 7 and onwards, it is basic or alkaline. Okay, that's what I wanted to give as an extra. But okay. Now, when the when it's 0, when the pH is 0, enzyme activity is 0. And when it increases, pH increases, enzyme activity increases. Till it reaches the optimum pH, which is 7. Now, it's not like that everywhere. This is just a normal. It's like this mostly. But in enzymes, it's different. Okay? So, pH is 7. The optimum pH is 7. Optimum pH is 7. Now, as it goes on and on, as the pH increases, the enzyme activity decreases. So basically, what you can make out is that it works mostly on the acidic and pure water part, right? So enzyme activity works better here. Why? Because a high or low pH inside, okay, so it needs either, like, it works best over here. So pH, I mean, it's working over here and it's still working over here, but over here it's not working at all, and over here it's not working at all. So either it's over here or it's over here. So a very low or a very high makes chemical bonds, a very low or very high, it makes chemical bonds inside the enzyme become broken. If it breaks, then the active site, the same story. So, and substrate cannot fix, which causes denaturation. So, now, over here, over here, so the optimum pH, over here it's obviously, okay, optimum pH, it is in an enzyme. In an enzyme, optimum pH depends on where it works. On where it works. Now, there are two examples that you should know. Okay? The two examples are either it works in the intestinal enzymes, either in the intestine, or if it works in the stomach. Okay, in the intestine or in the stomach. If it works in the intestine, then the pH is 7.5. The optimum pH is 7.5. If it works in the stomach, it is 2. pH is about 2. Okay? I explained all of that.